I think I will also stay on the chair so you can better look at the screen. I noticed it on my place. It's better if the people are sitting, then you see more from the screen. Okay, so what I will present today is called BAWT, and it's about build automation with Tcl. Yeah. I will show you a quick introduction. What was my intention to work on this package? Then I show you some examples, for example, how to build a small Tcl batteries included and the whole libraries I need for my Tcl 3D stuff. Then I will show you a little bit about the status, what's on the to-do list, and short summary. So that's the situation I have both for my private working, like Tcl 3D, depends on OpenCNgraph and lots of other libraries. At work we have, again, OpenCNgraph, several other C++ libraries like Boost, Xerxes, and all that stuff. It's quite fine if you have a lot of functionality from 3D libraries, third-party libraries, but one problem is how to build these. On Unix or on style system, Linux or Mac, it's not so a big problem, but the main problem is on Windows. I colored the corresponding libraries. The orange ones which are typically built via the GNU compiler, and the green ones are typically libraries which have to be built with Visual Studio. So that's the situation. And well, formally, either you try to get ready-made libraries on Windows for downloading, or at work, one of my colleagues, I think 5 years ago, all compiled these libraries by hand and put the pre-built libraries into our repository. That's why we are still at Visual Studio 2008, because nobody wanted to do that task again manually. And it's also a big problem because you never record which, let's say if you have something which you are building with Visual Studio and you clicked some configuration options, you never have you never know which compile options you compile that stuff. So this was the situation I was handling about several years, and here's what I wanted then to have. I wanted to have a build system where I can build all of these libraries in one batch job. Ideally, it is integrated in our nightly build, where we put out all our source code from the repository, build the software, and run our regression tests. So that's one of my requirements. Also, it should support not only Windows. It was the main intention. We had shell scripts which doing that stuff for Linux, but I don't want it to have several scripts and infrastructures for Windows and Unix. Then one major problem was also different Visual Studio versions. When we also intended to have a newer Visual Studio version compiling our software and the third-party libraries, who wants to do the job and try whether it works with Visual Studio 2010, 12, 13, or even 2015. So this should also be automatically. Then third point I already mentioned, I want to have the software be compiled from one job. So this was a problem because of MSYS MinGW environment, and the other one is in the DOS environment. And of course it should be relatively flexible, and I don't want it to have all the third-party sources which we don't change in the repository as a whole tree. For example, we are using the Boost library. If you check that out, it's several 100,000 files. It takes quite some time to check that out. So how did we solve that? It's, let's say we have the several libraries. I used some Tcl libraries here as an example. All the source code is put into a 7-zip compressed file, and we have a little configure script, setup script, and this should be transferred or compiled into a directory structure, so they should not only be compiled, but I also wanted to have separate folders for the developer, so the developer should have the debug files, the include files, all the libraries, and I wanted to have a separate branch where all the files are in it, so I can easily, that's the files I give to the client with my software. And that's what the BAWT framework is about. It's more or less just one simple Tcl script which handles all the functionality of calling the different compilers. And you have several setup files where you configure which of the libraries you want to compile. So I show you the workflow on a simple example. As I said, I want to have a small batteries included Tcl distribution, for example. I have the first one is some manual work. If you don't have the stuff on your computer, I have made a little page on my Tcl 3D site where you have the BAWT framework, the script, plus some bootstrapping tools. I use Tcl kits for bootstrapping. And you have some other bootstrap tools. As I said, I have compressed my source trees with 7-zip because it compresses better than the normal zip. And for Windows, you also have 4 different MinGW MSYS environments for different compilers and for 32 and 65 bits. That's the files you need for bootstrapping. Then you have, I supply several, let's say, for simple Tcl batteries included. I have setup files for my Tcl 3D project, and I have a setup file for all the libraries which are currently supported by BAWT. And you just write a simple setup. You said setup is a command or procedure from the BAWT framework. You said, okay, which library I want to compile, where is the source file, which is the configure script, and you can add the build types. You can choose between release or debug or both. And therefore it's very important that we have the G at the debug libraries. The build or distribution process is divided up in several stages. There are two general stages at the beginning and one general at the end, and these 4 stages are for each library. So the first one is the bootstrap program or bootstrap step. It uncompresses the 7-zip program with the ability of the Tcl kit and puts it into the build directory, and it also extracts the MinGW environment you need for compilation. In that example, I want to build a distribution for 32-bit and on Windows. So it puts up the correct file. Then in the setup file, it reads or sources the setup file you have seen. There it reads, okay, which of the libraries which are available does it want to compile. It looks up in a directory, are these files already existent? If not, it downloads it from the BAWT server, and that's it. Then you have stage clean. So if you already had build that library, it removes these directories from the build directory. I go through the stages by the example Tcl UDP. So we already have a build directory, we have an install directory, and I have built all these libraries. Clean removes these directories, so you can freshly start. Next stage is the extract stage. So it just extracts the compressed file and copies it into the corresponding build directory. Next stage is a configure stage. Here it runs, you see, it always writes a log file, so you can see what it's doing. And what I'm calling here is more or less a standard configure with all the correct options for Tcl UDP, for example. And then we have the make file in that build directory. Then the next stage is a compile stage. There it calls also standard make and make install commands. And then you have the compiled package in the install directory. And there's a final stage for the library dependent stages. It copies all these files, or the files you specify in the corresponding config file, either in the development branch, which is a branch I use as a developer. So it copies include files and stuff like this. And it copies relevant files into the distribution part. So here it only copies, for example, DLLs and stuff like this the normal user needs. And then in the finalize stage, you can hook up a user-supplied finalize procedure, so you can do tasks at the end of such a compile or distribution process, which are, let's say, project dependent. For, let's say, the simple Tcl distribution, I don't have a finalized procedure. And let's say for the how I use it at work, we have several scripts and other tools or license files we will copy into the distribution directory. And it gives you a nice summary, so you know how long each package took. And as you can see, for example, Tcl image, that really takes long on Windows because it's the configure part is so time consuming on Windows. So that was an example. Here is an example how the script looks like for building one library. It's currently very simple. You have to define a procedure which is called build underscore and the name of the library. It expects several parameters, and you have the BAWT command use stage. So it knows in the stage extract, you call the procedure extract library, which calls 7-zip and copies the file into the corresponding directory. You can also extract library knows or detects if it's really a 7-zip or if it's a directory. So if you are testing a new library, you can hold that source directory as a directory, and it just uses that. And if you are finished with that, you can compress it into a single file. Then you check if we are in the stage configure. You build up configure script. You can use, as it is a Tcl script, you can have such utility functions like are we on a 64-bit machine, or do we want a debug build, and append the different configure commands. And then you have the command MSYS run, and this opens up a MSYS shell and execute the correct configure command. Then stage compile. There is a higher level MSYS build, which just does the same as MSYS run, but it knows, okay, I want to have call make and with a corresponding target. And then in the distribute stage, you can copy the files you need into the different directories. One is the dev directory, which I said is the directory I want to use as a developer. The other one is the distribution directory. And here you also have some utilities to easily copy files or rename. For example, I rename the UDP, it's typically called UDP, and the version I just rename it to lib/UDP. So here's a little bit more complex setup file, which I am using for my Tcl 3D library. Here I need several other libraries like the standard zlib, GIF, and so on, which I need for OpenSceneGraph. You can also, as I mentioned, generate Tcl kits out of that process. And here I not only have this BAWT configuration file, but I also can copy, let's say, or supply icon and resource files and say, okay, when building the Tcl kit, use this icon file and use this resource file, and you get a Tcl kit with your logo and with your Windows attributes. This is more or less taken the code from René's KBS kit. And as you can see, you can also, for example, on Windows, I supply the binary CMake program, because then you have a nicer GUI. For Linux system, I use a source code and compile it, so I only have the command line CMake. And it goes on, and all these libraries can be compiled. So Swig, tools, and all that stuff. So I have shown you a little bit the workflow. Here you see several commands which I supply. One is for configuration. We already saw the MSYS run, which executes a command in the MSYS shell. Then you have the DOS run, which executes a command in a normal Windows DOS shell. And you have for CMake builds, you have a CMake config. For compilation, you have CMake build, nmake build. For nmake files, ms build. Then for Visual Studio project files, you have the MSYS build for MSYS builds, and you have such utilities to convert generated DLS into import libs, which you need if you compile your project with the libraries. You need these import libs on Windows. And then there are several utility procedures for copying files, extracting files, and see, okay, in which platform I am, and so on. And these can be used if, let's say, some projects or tools or libraries need special environment variables. For example, geographic lib, you need to set a geographic lib data environment variable to point to your data files. So you can also specify these in your configuration script, and then it spits out in the finalize, it spits out a .bat file where it sets these environment variables pointing exactly to the location where you copied them to. And let's say you can add to path environment, say, okay, these and that tools, for example, if I want to call Tcl from the command line and Swig and all these tools, I can add the paths to these tools to the environment variables. It has several options. One are, let's say, for the library-specific configuration is done in these setup files, and it has several options to specify, okay, want to use a 32 or 64-bit compilation, which compiler, especially Visual Studio version I want to use, then you can also choose the GNU compiler version, and you can override the build types which are specified in the setup file if you want only a release or only debug build. You can also specify the number of jobs so you can compile in parallel. So what do you need on Windows? If you want to compile Tcl, TclKit and TEA compliant Tcl extension packages, you don't need anything. You don't need MSYS, you don't need a Visual Studio compiler, you just need to download the 2 or 3 bootstrap files from my server and then start the script, and after a few minutes or hours, depending on your machine and the number of libraries you had, you get a final compiled Tcl and Tcl packages. Oops. On Linux and Darwin, I don't supply the compiler, so for Darwin you need to have Xcode installed. For Linux you have to have the C++ development packages installed and several minor things. And the other thing is nearly the same, just extract the framework, make sure the build and Tcl kits are executable on Linux, and then you have start the distribution and compile process, and there you go. So, as I said, this is a work in progress report. It works for me privately, it works at our company, but before giving it into the wild, I think there has to be done lots of more things. For example, improve error checking and handling, of course, lots of things. Or what I don't have and I want to implement is strip the DLLs and libraries if in release mode, so you don't have the symbols in it. Then debug libraries, I don't test it for each library. I have only the ones OpenSceneGraph and a few others which we are heavily debugging also at work. Then more flexibility in all kinds of handling. Yeah, there is no documentation yet besides this presentation. And maybe add more Tcl packages. Currently I have few for testing and the ones I'm using, but there are lots of Tcl packages which could be easily included. Then I have some questions to the Tcl experts, because I have, let's say, found some problems when experimenting with the stuff. I compile Tcl and Tk itself with a GNU compiler in the configure stuff. But if I compile it on Windows, I don't get Tcl stub libraries. I get stub libraries libstubs.a, but this I can't use, and I didn't find a way how to import or convert these into a import file library, which I can use from Visual Studio. So my trick currently is...
I don't think you can.
The only way is to generate it with Visual Studio.
Yeah, that's what I'm doing currently. So I have the same source package. I compile it once with GCC for using it, and I just compile it with nmake Visual Studio to have a Tcl stub import library. So if there's no better way I can. The other thing I noticed, if I compile Tcl with a GCC, it has a rm-rf packages in the configure script. So I didn't get the SQLite and then the TDBC stuff compiled.
It removed, but it doesn't. That's removing the built version of those packages.
No, it removes the source in
No,
865.
Do you run the build from the Win directory or in the top directory? If you do it from bin directory, I think it's used to remove the binary stuff before.
Yeah, it should be removing just built versions. It shouldn't be removing.
Yeah, because in my simple case, I don't have a separate build folder. I build it in the source directory. And there's only this statement, so it removes the source.
That seems a Pupil's problem.
And maybe there should be some top or anything
It should
before.
be
and
source.
correct
Should be
that.
relative to the correct directory.
I never built it in the source directory, so.
Yeah, but that's what it's currently doing. I'm building it in the source directory, and then it removes my source package
I always
directory.
build it in the Linux directory
So
or
this
in the
bug
directory.
report. Okay. Yeah, and the other stuff is how to generate these Visual Studio import libraries. Is there a way to generate these without having Visual Studio?
No.
Because as you have seen maybe in the, what did I have? I have here that special command create import libs false. So if I want to generate just a Tcl runtime, then I can compile everything without having Visual Studios. Normally, let's say if I compile developer versions, I need at least one Visual Studio version so I can generate the Tcl stuff and these import libraries I need.
Those lib import libraries, they are used to link against Visual Studio. So,
Yeah, because let's say my main application is built with Visual Studio, so and these are targeting others like Tcl and so on. So I need import libraries for all these stuff.
yes, import library and the script library should be built with the same compilers.
Yeah.
Linking with later. No, I don't know of any MinGW tools that use that.
Yeah, that's
They always create .a files.
what were, let's say, three main things I was running into, and I thought if I have such a good community of experts, maybe there's a better way like I do it now, but as far as
No, there is not.
besides this second point, maybe
I think
that's,
the libs are indeed not compatible between compilers.
yeah,
And GCC doesn't need import libraries.
yeah,
You can link directly against the DLL.
mm,
But I don't think you can do one thing and use the results in the next.
yeah, so if I want to create developer versions, I have to use the correct Visual Studio version.
The reverse is possible. If you use lib files and you generate them with Visual Studio,
Yeah.
you can use that with MinGW. That is possible. The other way around.
Okay, so up to summary. As I said, I'm using it for my private open source project since several weeks now, more or less in production. We have introduced it in the project I'm working at work. So it runs fine there on Windows and Linux. And what's interesting from my point of view, if you have because of this bootstrapping process, you deliver the MinGW and the 7-zip. Now everybody, without having knowledge about C compilers or having a C compiler or MSYS installed on his Windows computer, should be able to create his own Tcl batteries included, more or less. And let's say I have downloaded the sources or the libraries I can currently I support onto that subdomain of Tcl 3D, BAWT and Tcl 3D. And I would like to thank a former student of mine, Stefan Mollner, who wrote the first version of this as implemented as DOS batch files. And he mainly did all the tricky parts, how to call the MSYS shell from a DOS shell, how to get the right compiler and all that stuff. So many thanks to that student. And maybe
Not very many students with these capabilities nowadays. Really.
Wait a minute. What we get about? Okay, it doesn't like from the. Where's my doc? Does anybody know how I can get my doc back?
It's on the screen.
Ah, oh. Okay, and that's let's say the framework, the tools you need for Windows. I have also copied a 7-zip version for Darwin. For Linux you can install it, and this is a list of all the packages which currently run with BAWT. So Tcl TK, separate distribution for the stubs, the Tcl kit, these are the compiled Tcl packages, TWAPI, table list, several tools like CMake, Swig, basic libraries, setlib, GIF, then 3D libraries I use for Tcl 3D, and other like Boost, KDIS is a DIS simulation middleware, Xerxes XML library, and so on. So these should run now on with this tool. So if there are any questions. I think Martin was first and then these two guys.
How much work is that to add another library?
This should be quite easy.
You want to add tree control or something like that?
If for example, if you would add, let's say, TIA compliant libraries, you look for one and just make copy and change a few configure settings. The other, let's say, it depends on the complexity of the library and which build system it supports. Some are very tricky to find out. Others, like TIA compliant libraries, should be very easy to implement.
So, for example, EuroTcl should be using because it's still compliant.
Yeah. And you guys?
I'm a little bit reluctant to believe that MinGW and Visual Studio compiled versions of Tcl are really interchangeable. Because a few years ago I had the Sigwin and the active state distribution installed in parallel, and I can remember that one way around, I don't know which way, if one of these tried to access a DLL which was compiled for the other one, I had crashes, and the other way around.
They don't access any other libraries, it's just a stub library.
Sigwin and MinGW are different. They have different runtimes.
And it's not Sigwin, yeah?
Runtime is not compatible with Windows. MinGW runtime is compatible with Windows.
Okay.
Sigwin is an abomination. Don't use it.
Okay.
Sigwin is not Windows.
And MinGW is compatible enough.
Good.
Looks.
Okay.
So I find this is quite interesting and quite useful. Once I had to make a small change in this UDP package,
Yeah?
and I had to compile it. The first problem was I had Visual Studio, the Studio 2005, I think, and what you get if you download the source code, that is a project file working up to Visual Studio 2003.
Yeah, that's a problem.
Because
But
of
you
the
should
manifest.
you should compile all these TIA compliant libraries with GCC.
Yes.
Yeah.
So that was a real problem.
And
I managed to patch somehow the
Yeah.
executable.
That's also the problem with, like, say, the Xerxes library comes with Visual Studio project files only.
Yeah.
But I managed to, okay, the current version goes till 2013, and I just more or less copied the 2013, imported it into Visual Studio 2015,
Okay.
let it Visual Studio reorganize and upgrade and store that as a new one. So from time to time, if packages don't have a good build infrastructure like Tcl has, then it's
And exactly this is the tricky, dirty part.
yeah. If you are using, let's say,
Yeah.
other libraries, typically for Tcl it's very straightforward. You have to
Yeah.
use a configure. Some packages have other, let's say, options you have to specify or not to specify, and so adding Tcl extension packages should be very easy by just copying existing code
Okay.
and
Okay, so in the past I have used KBS kit from René
yeah.
to do more or less the same, because the motivation was to distribute BAWT, and that was a very annoying thing to compile it on like 5 different platforms. And I think I can compare it to that, and there are it's inspired probably. But one thing I think that it does, what your system doesn't, is you can download from many different sources the source packages. For example, you can get CVS, SDN, you can HTTP, and to suck basically the source package from the internet and then compile it. Do you have provision to?
Currently not, because the main intention was that, let's say, for where I started was at work. So we have a really fixed, let's say, configuration of source files and so on, and only if we would release or test a new version we would upgrade, and we don't want to use a version from repository here and from there. So we wanted to have really tested and stable packages. In principle, yes, as I said, I have, let's say, the download feature via curl in it. So in principle, it should be possible to extend, let's say, the procedures and point them to other URLs to download something. That's also what I mentioned, more flexibility in how to handle that stuff. Currently, as you saw, it has always the package name and the revision number, but inside of the compressed file, it only has to be the directory with a pure library name. So I also don't handle different, let's say, library versions of one package.
Then I think that KBS has a patch feature, so you can download the sources and then apply a short patch on it.
Yeah.
And for example, you could patch out this annoying RM minus RF easily from KBS.
Yeah, currently that's, I have also patched several libraries because, let's say, make files and stuff like this, but I did that
And you save the
manually and write the notice in the .z file. So I said, okay, that's a GIF version, so, and I have patched this line in make file, for example, because I say, okay, I'm using the GIF library in that version the next 2 or 3 years, of course. I don't want to update that. But
And then as a final comment, you have shown one example for how to add a new package. And I'm not sure if it was the simplest example, but in the KBS, this syntax is very concise. So just to compile BAWT, it's like 5 or 6 lines, and there is no special options. So just like configure, patch, execute. And for TR compliant things, it just works. So how complicated is it? It's more or less the same question. How complicated is it to add something?
yeah, I've seen, so let's say the detailed, correct me if I'm wrong, but looked a little bit in KBS kit because I wanted to have a Tcl kit also automatically generated. And there for every, let's say, package you support, there's these lines are inside the KBS
Yeah,
dot
okay,
Tcl.
yeah.
And I have put that out so I have real control without having to change the build script itself. So this should be very generic, and things I have to change regarding to a new library or a changed library, I have put out in this configure script. So you're right, you have more, for example, TIA compliant libraries, you have more redundant code outside, but you are more flexible without changing the framework itself. So that's design decision. And what you can also maybe as a, okay, we're a little bit over time, just as a little final note, something while waiting for the plane yesterday, I have added a new target. It's called Tcl setup, and it just generates out of the distribution stuff. It uses inu setup, and you get a installer. Oops, I'm not on the right one, so I cancel it. So here you are in that build directory where it has built the Tcl distribution, and there is a new target where you can also generate a setup file. So then you get a Tcl setup, and you can easily install Tcl. So, and then you have, let's say, your Tcl in the menu. What I added is the install and the wish shell, and then here you are. Ready. And if I don't like it, I just uninstall it. And away it is. And that's, I made this virtual machine because it's pure naked, no Tcl on it, no compiler on it, and you see that the build process runs on such a machine. Okay, so far. So